Today we're going to be talking about Webpack in all its glory, as well as its confusion. What is Webpack? From a 1,000-foot view, Webpack is a module bundler for JavaScript applications. It is an NPM module that we'll be utilizing for our development. We'll be using this throughout all the videos that you'll see from here on out. Using loaders, processors, and plugins, it makes developing a complex application much simpler than it would be to manage global scoping and file load order. Previously, we had to load files in the proper order to ensure the global objects were available to the scripts following a given script. For instance, if we're attempting to declare an Angular.module in file A, and Angular is loaded second as file B, Angular will not be defined when file A is executed. This will cause an undefined exception, and your application will fail to load. That's because the Angular object is not available in file A. Previous solutions included means of managing file loading order by a term called blobs. These blobs were expressions that would match a given set of file patterns. They would be loaded in the proper order at that point based on the file matching it. The problem is certain blobs tie you to a framework you've chosen. For instance, we named Angular module declarations myComponent.module.js. Since those files needed to be declared first in our index page, we would grab a blob that would match those files and put them in order necessary for the remaining scripts. Enter Webpack. To eliminate the messiness of blobs, Webpack allows for the use of ES6 modules. We'll cover this in a later video. However, these import and export statements allow for the proper ordering of files, as well as making your application much easier to understand because it's more declarative. But wait, there's more. Webpack also handles the following: styling, such as CSS, Sass, and less, which are a few preprocessors that we can get into later; image loading; transpiling, changing from one language into another; source mapping, to take those transpiled code and put them back into source; file copying and manipulation; as well as hosting content. The first aspect of Webpack that we're going to delve into is loaders. A loader is simply a set of code that transforms a given source file in your application. It runs in the node environment and are typically installed via npm. Loaders can be chained together to perform multiple transformations before being bundled into your application. One note to make is when installing loaders, they will typically be named something-loader. The loader portion is dropped when interacting with the loader in your Webpack configuration. A few examples of loaders is as follows: Babel, which is used to transpile ES6 JavaScript into ES5, which is more natively supported by browsers. CSS, it allows for the importing of CSS files that then get appended into your index page. File, this loader copies over files from a given directory into the distribution directory. And Pug, which we use in order to write an HTML replacement language called Pug. We'll be getting into the syntax and the use of that in a later video. The anatomy of a loader configuration is as follows. It contains a test, which is a regular expression used to identify the set of files; a loader, which is a loader string representing what loader to perform on that set of files; or you can provide it an array, which is a collection of loader strings that will then be performed in the order of declaration on that set of files. A loader string is simply the name of the loader. However, it can also take query parameters. These query parameters modify the behavior of a given loader. A few example objects representing these loader configurations are as follows. You can see my Pug loader in the beginning, which is the most basic form of loader. Next, you can see the loader for Babel, which does the transpiling from ES6 into ES5. This allows for both ES6 file extensions as well as JS. We exclude the node modules directory because we don't want to perform the Babel transformation on our dependencies. Finally, you see the importing of font files using the file loader. We move those files from the file location directory into public/fonts and then give it the name that it contained within its directory. Next, we're going to talk about plugins. Plugins are very similar to that of a loader. The difference is the plugin applies to the bundled application and not a particular file type. It can also listen into the build process of Webpack. Setting up a plugin is also significantly easier. You simply create a new instance of the plugin and configure it as you'd like according to its API. You then add it to the plugins collection of the configuration. We'll cover more of the configuration file and how it's used in the next video. A few examples of plugins are as follows. You can see that I declared a new HTML Webpack plugin, which generates an index.html page from my index.pug page. In addition, I also copy over my assets from one directory into my distribution directory. Next, I use a set of built-in Webpack plugins that are used to enhance the build process by optimizing the way it's loaded as well as how it interacts with my development server. Next, we're going to talk about the resolve object. The resolve object handles file names within your application. If you're attempting to import a file that is extremely long, or you import many files from a directory, you can use this object to make that a little easier. The root property is a collection that tells Webpack to look for file names in a given set of directories. This is useful when you import many files from a given directory. For example, I'm resolving the source directory as well as the node modules directory for my application. This means I can access files within either of those directories via a relative URL, and Webpack will find those files in those directories. Next, we have the alias. Aliases are for mapping a given import statement to a specific file location. This is useful for projects that don't have a main property in their package.json file. Webpack will attempt to load the main file described in the package.json for a given directory name. If it does not find that file, you'll get a module not found error. Using alias, you can tell Webpack where that file should be found at within the given directory. Now we'll talk about the output object. The output object contains two properties, path and file name. The path indicates the output directory. I use __dir name, which is a Node.js variable that stores the current directory in which the script is executing, as well as the path npm module. This module is used to do path manipulation. Here we are telling it to resolve the dist directory of our current directory that we're executing in. It will create the necessary folder if it does not exist. Finally, the file name is the output bundle from the Webpack build process. We're simply going to call it bundle.js for now. And now we'll talk about source maps. Source maps, generally speaking, are a way to view the source code from a transpiled code base. This can apply to more than just JavaScript, such as Sass and other forms of transpiled code. The importance of source maps is that you'll want to debug your source code and not the transpiled code. From the example of transpiled code below, you can see that there's a lot of difficulty in reading it, as well as the fact that there's a lot of boilerplate that is put on top of your source code in order to make your code work. This is extremely important with transpiled code because Babel, for instance, will modify your code to a nearly unreadable state. Implementing source maps in Webpack is actually extremely easy. There's a DevTool property that you'll want to set in your Webpack configuration. I personally use SourceMap as my DevTool as it provides the greatest functionality, and my application is currently jokingly small, so the benefits of efficiency from the other one wouldn't really be noticed. Lastly, we'll cover how to install Webpack into your npm project. To install it, simply perform an npm install -g savedev webpack. That's it. Remember though, we want to save dev to ensure that we are noting it as a dev dependency. In addition, I want you to note the -g. The Webpack npm module comes with an executable bat script that will interface with your file system natively. If you execute Webpack in your current directory via a command prompt, you should see it output the usage information. We'll expand on how to configure Webpack in the next video. To wrap it up, what I covered here is very minimal information about Webpack. There's a lot more you can do, there's a lot more that you can do wrong as well. A lot of the information is out there and available via the Webpack configuration website. A lot of it you'll have to find through trial and error and Stack Overflow for sure. Remember, as always, you can contact me via LinkedIn, Twitter, or leave any comments in the video down below. I look forward to teaching you the Webpack configuration in the next video and hope that it comes soon.